Stages in a data science project. Any project starts with a well-defined problem statement, like forecast the sales of an X item, present in its inventory in the coming month, or the cause of customer churn, or a not well-defined problem, like how to increase sales of a product. Data science enables us to solve this business problem with a series of well-defined steps. Generally, these are the steps we mostly follow to solve a business problem. All the terminologies related to data science falls under different steps, which we are going to understand just in a while. Step 1. Business understanding. Step 2. Collecting data. Step 3. Pre-processing data. Step 4. Analyzing data. Step 5. Data modeling. Step 6. Model evaluation. Step 7. Model deployment. Step 8. Driving insights and generating buy reports. Step 9. Taking a decision based on insights. Let us discuss these steps in detail. Step 1. Business understanding. The business need is the starting point in the life cycle. Hence it is important to understand what the problem statement is, and ask the right questions to the customer. That helps us understand the data well, and derive meaningful insights from the data. A few right questions that other successful businesses have asked in the past are their data science teams. 1. Uber. What percentage of time do drivers actually drive? How steady is their income? 2. OYO Hotels. What is the average occupancy of mediocre hotels? 3. Alibaba. What are the per square foot profits of our warehouses? All these questions are a necessary first step before we can embark on a data science journey. Having asked the correct question, we move on to collecting data. Step 2. Collecting data. After gaining clarity on the problem statement, we need to collect relevant data to break the problem into small components. The data science project starts with the identification of various data sources, which may include web server logs, social media posts, data from digital libraries such as the U.S. Census datasets, data accessed through sources on the Internet via APIs, web scraping, or information that is already present in an Excel spreadsheet. Data collection entails obtaining information from both known internal and external sources that can assist in addressing the business issue. Normally, the data analyst team is responsible for gathering the data. They need to figure out proper ways to source data and collect the same to get the desired results. Step 3. Cleaning data. After gathering the data from relevant sources, we need to move forward to data cleaning. This stage helps us gain a better understanding of the data and prepares it for further evaluation. It entails steps such as selecting relevant data, combining it by mixing datasets, cleaning it, dealing with missing values by either removing them or imputing them with relevant data, dealing with incorrect data by removing it, and also checking for and dealing with outliers. By using feature engineering, you can create new data and extract new features from existing ones. Format the data according to the desired structure and delete any unnecessary columns or functions. Data preparation is the most time-consuming process, accounting for up to 90% of the total project duration, and this is the most crucial step throughout the entire life cycle. Step 4. Analyzing data. Once your data is ready to be used, and right before you jump into AI and machine learning, you will have to examine the data. Start digging to see what you've got, and how you can link everything together to achieve your original goal. Exploratory data analysis, EDA, is critical at this point because summarizing clean data enables the identification of the data's structure, outliers, anomalies, and trends. These insights can aid in identifying the optimal set of features, an algorithm to use for model creation and model construction. First of all, you will need to inspect the data and its properties. Different data types like numerical data, categorical data, ordinal and nominal data etc. require different treatments. Then, the next step is to compute descriptive statistics, to extract features and test significant variables. Testing significant variables often is done with correlation. For example, exploring the risk of someone getting high blood pressure, in relations to their height and weight. Do note that, some variables are correlated, but they do not always imply causation. Lastly, we will utilize data visualization, to help us to identify significant patterns and trends in our data. We can gain a better picture through simple charts like line charts or bar charts to help us to understand the importance of the data. Step 5. Data modeling or machine learning modeling. Throughout most cases of data analysis, data modeling is regarded as the core process. In this process of data modeling, we take the prepared data as the input, and with this, we try to prepare the desired output. We first tend to select the appropriate type of model that would be implemented to acquire results, whether the problem is a regression problem, or classification, or a clustering-based problem. Depending on the type of data received, we happen to choose the appropriate machine learning algorithm that is best suited for the model. Once this is done, we ought to tune the hyperparameters of the chosen models to get a favorable outcome. Finally, we tend to evaluate the model by testing the accuracy and relevance. In addition to this project, we need to make sure there is a correct balance between specificity and generalizability, which is the created model must be unbiased. Step 6. Model evaluation. Model evaluation is the process through which we quantify the quality of a system's predictions. To do this, we measure the newly trained model performance on a new and independent dataset. This model will compare labeled data with its own predictions. Model evaluation performance metrics teach us 1. How well our model is performing. 2. Is our model accurate enough to put into production? 3. Will a larger training set improve my model's performance? 4. Is my model underfitting or overfitting? Step 7. Driving insights and buy reports. In this process, technical skills only are not sufficient. One essential skill you need is to be able to tell a clear and actionable story. If your presentation does not trigger actions in your audience, it means that your communication was not efficient. It should be in line with business questions. It should be meaningful to the organization and the stakeholders. Presentation through visualization should be such that it should trigger action in the audience. Remember that you will be presenting to an audience with no technical background, so the way you communicate the message is key. A few tools used for viz purpose. 1. Tableau. 2. Power BI. 3. R. ggplot. 2. Lattice. 4. Kibana. 5. Grafana. 6. Spotfire. 7. Python. Matplotlib. Seaborn. Plotly. Step 8. Model deployment. Before the model is deployed, we need to ensure that we have picked the right solution after a rigorous evaluation has been. Then it is first deployed in a pre-production or test environment before actually deploying them into production. Whatever the shape or form in which your data model is deployed, it must be exposed to the real world. Once real humans use it, you are bound to get feedback. Capturing this feedback translates directly to life and death for any project. A few frameworks used for model deployment. 1. Flask. 2. Django. 3. FastAPI. Popular and widely used cloud providers are 1. AWS. 2. Azure. 3. Google Cloud. Step 9. Taking actions. Actionable insights from the model show how data science has the power of doing predictive analytics and prescriptive analytics. This gives us the power to learn how to repeat positive results, or how to prevent negative results. Based upon all the insights we have gathered through observation of data, or through machine learning models result, we get into a state where we can make some decisions regarding any business problem at hand. Few examples are: 1. How much stock of item X do we need to have in inventory? How much discount should be given to item X to boost its sales and maintain the trade-off between discount and profit? 2. How much attrition is predicted, and what can be done to avoid the same?
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.